Solving inequalities using multiplication and division. To solve and graph an inequality, we are going to use inverse operations to isolate the variable just as you would solve an equation. The inverse operation of multiplication is division, and the inverse operation of division is multiplication. Reminder, when graphing an inequality where the number is a solution, we use a closed circle. And when graphing an inequality where the number is not a solution, we use an open circle. Two properties, the multiplication property of inequality that states when you multiply each side of an inequality by the same positive number, the inequality remains true. The division property of inequality states that when we divide each side of an inequality by the same positive number, that inequality remains true. Now, things are a little different when you multiply or divide each side of an inequality by a negative number. What you need to do is you must flip the inequality symbol anytime you multiply and divide both sides by a negative. Negatives work in reverse. They look like they're getting bigger as you go to the left because we all have learned that 5 is bigger than 1. However, in negatives, it's the opposite. Negative 5 is smaller than negative 1. So we need to take that into consideration with inequalities. Let's look at an example. We are going to solve and graph this inequality, and we have negative 2 times g is less than or equal to 1. Opposite of multiplication, because we want to get g isolated, the opposite of multiplication is division. We are going to divide each side by negative 2. Here's the step that we need to look at. If both of these numbers are a negative and we are dividing, we have to take this inequality symbol and we will flip it. It goes from less than or equal to being greater than or equal to. I did cancel out the negative. I canceled out the number. The inequality symbol has been switched. And I have 1 divided by negative 2, which is negative 1/2. Now, I'm going to go down here and I'm going to go to negative 1/2. Negative 1/2 is halfway between 0 and negative 1. It does have that line underneath, therefore it will be a closed circle. And I want my numbers to be greater than, since g is greater than or equal to negative 1/2. Greater than direction is to the right. And now I'm going to check my answer. I can pick any number that I want from this shaded side. 0 is always an easy number to pick. So I'm going to select 0. I'm going to test, is negative 2 times 0 less than or equal to 1? Negative 2 times 0 is 0. It is less than or equal to 1. That shows that we had to flip that symbol to take into consideration the negative. The next example we have is h divided by negative 8 is greater than negative 1/2. I want to get h all by itself. Therefore, I need to do the opposite or the inverse operation of division, which is multiplication. And I need to cancel out the negative and the 8. Here's this step that I need to look at because I'm multiplying and dividing. Am I multiplying both sides by a negative? And the answer is yes, I am. Therefore, we need to flip that inequality symbol. I am able to cancel out the negative and the 8. I have isolated h. 2 negatives make a positive, and I take 1/2 times 8, which gives me 8 over 2, and that simplifies to 4. There is no line underneath, so I do an open circle at 4, and I want h to be less than 4, therefore I shade to the left. I can pick 0 to check my answer, so I'm going to check if 0 divided by negative 8 is indeed greater than negative 1/2. Well, 0 divided by anything is 0, and 0 is always greater than negatives, so that checks out.